That's actually, that's chapter 7, isn't it? So let's do a separate thing on alloys. Oh yeah, and I can put it in whatever order I want. We are on, right? I'm working? Okay. So let's do this. I think we ended the last thing. So we're going to do molecular modeling here very quickly. We'll do 2 or 3 examples, a quickie, okay? So my suggestion to you is to write down all of the molecular models so that you know what they are. And you can write like in 1 sentence or less what they are, you know, how you identify them. Because I know that there must be good 5 or 6 questions on molecular models. Yes? Okay, so you take the first thing you do is you write this, I think I said you write the formula, which we did that, AlCl3, then you have to write this.
Is this chapter?
This is 8, yeah. And then you do the valence, 3, 7, 7, 7. That's group 12 is plus 3, right? Yeah, in other words, it needs 3. It has 3, sorry, it has 3, it's going to give up 3, correct? It's 3s2, 3p1. That's going to be 17, and that's going to be 7. It's going to have 7 electrons. In other words, the total number of electrons that are available for bonding. Remember, in bonding, we only use s and p electrons, and they're called valence electrons, and that's all you use in bonding. Is this right? Am I doing this right so far? So that's what, 24?
Yes.
So that's going to be minus 6 is 18, and then subtract, I'm not going to put them in, 6 each. Are you with me? Am I going too fast? Red, you look a little stunned. You look like the parrot from Monty Python. You don't know who that is? It's a good thing. I incredibly insulted you. No, I'm kidding. The dead parrot sketch. Okay. The parrot wasn't dead. The parrot was stunned. Okay. So, it's better than Crunchy Frog. Okay. So then that's it. And remember, a metal has less than 8, usually, and the non-metal has 8 or more. Okay. So that's done. No excess electrons, so it's going to be trigonal planar. Okay. You all right with that? Lula, are you with me today, or you sure? Are you? Everything's good?
Yeah.
Excellent. There's a smile. I was looking for that smile. It's the first smile since you've been in here today. Excellent.
Trigonal, planar, and polar and nonpolar.
Well, it would be nonpolar because it has a regular geometry, and all the atoms, all the outer atoms are the same. That was big, what I just said. Do you understand that? In other words, it's a regular geometry, and all of the outer atoms are the same. In other words, you have dipoles. All 3 bonds have a dipole, all going towards the central atom, right? Or away from the central atom, all going towards the chlorine. So they're going to cancel, yes?
Yes.
One of the exceptions to that, where it's an irregular geometry, but it ends up to be nonpolar, I'll do that one. I'll do xenon tetrafluoride. You guys know this one? Okay, so it's going to be 8 and 28. Can I do that quickly? Is that all right? 36. I'm kind of giving it away. Okay. Yes? So minus 8, 28. So 6, 6, 6, 6, right?
24.
24? No, that's 3 instead of 4. Okay, so it's so silly. Okay, so 4. So I have 4 left over.
Yes, you do.
I'll tell your mother you said that. Okay, I just want you to know. Well, I'll tell her anyway. You'll have to explain. So you put them here. Okay.
Yep.
Yes.
Yep.
So what you have is, you have above, you have four like this coming from the central atom, right? Like this, right? Four like this coming from the central atom, and then you have a non-bonded pair above and below, right? Is that pretty awful? You get it though? Yeah? Are you making fun of me, Nora? I just want you to know that I'm very upset. Okay, so in other words, you get four bonds literally across from each other, not tetrahedral, four planar, so it's square planar. Yes? Kaylee, you have a question on that?
Let's double check what you call the form.
You want to double check what?
What you call the
Square
structure
planar.
form.
Square planar. Now, again, that's not a regular, what we call a regular geometry. What are the regular geometries? Linear, trigonal planar. Just count the number of bonds. Tetrahedral, bipyramidal, trigonal, bipyramidal, and octagonal, right? Yes? All right. All right, shall we do one more? We'll do a funky one?
Yeah.
All right, let's do chlorine triiodide. All right, we'll do two more. We'll do, this is one. I'll do it quickly. I don't even know if this is going to work. I mean, we're just playing here, aren't we, really? So I've got 7, right? So 28 minus 6 is what? 22 minus 18? 4. So what's that going to be? Now remember this, that you have the trigonal bipyramidal, right? So you have this. You have 2 bonds coming above and below, right? And then you have 3 like this, right? Equal, right? Like this, right? Right? Now that's regular geometry, right? I take 1 off and I get a seesaw. Right? I take 2 off and I get a T. I take 3 off and I get a linear. Right? So there are, remember, 2 are above and below. So I only got 1. So it's going to be what? It's going to be a T. Right? Because seesaw, T, linear. You get it? Okay. Let's do one more quickie and then we'll end with that.
Mr. Arcee,
Yes.
for the test, will we have to know the names of each thing, for example, T and will we have to know the names for them?
I don't know if the real exotic ones are there, but yeah, you got to know the names of all the geometries. Yeah. I don't know if I want to be as specific as if do you have to know T.
No, like, I was just,
Yeah. And I think I said about 7 minutes ago to write down.
I have like all like written down in somewhere.
Yeah. That's important to have in your notes. Yeah. Yeah, I don't like to ask you to memorize stuff. I want you to be able to use what you have written down, because there's a really great invention out there when you go into the real world. It's called books and the internet. I know. It's amazing, really. It's really amazing. I know. So you can look that stuff up. I'd rather you be able to think than to memorize something, even though memorizing is not a bad thing. It's just sometimes a waste of time. Okay, so shall we do one more quickie?
Sure.
Let's do this one, because I want to do the next video on this. Okay? Yes. So it's going to be this. Correct? You all right with that? Yes or no?
Yes.
Okay.
Yes.
And then you get 4, 4, 1, 1, which is 10 minus 6 is 4.
And then 2 on each, right?
Is that right?
Minus 6.
4, 4 and 4,
Yeah,
1 and 1. So we get minus 6, which is 4. So what do you do with them?
Now
2 on each side?
2 on each, good. Yeah, when in doubt, just split it up, okay? Because we are talking about sharing, aren't we, after all? This is definitely 2 nonmetals, it's definitely covalent. So what are we going to do? We need 4, this has 2, 4, 6, 2, 4, 6. How do we get 8? Yes?
Couldn't you just do a double bond between the 2 C?
A double bond, all right.
Yeah.
The electron's got to come from somewhere. So I get 2, 4, 6, 2, 4, 6, 8. But this one only has
Double bond again. Triple bond.
double bond again, a triple bond. I like your style. And that's it. Excellent. And what would we call that? We call that a triple bond. Excellent. Thank you. I can count. But what would we call the geometry? Linear. I mean, arguably linear. This might be a little bit like, could be like that. I mean, yeah. Could be that. Could be that. I mean, when you get into 4 atoms, you're not really talking about linear anymore, or you're not talking about geometry. It's kind of funky geometries, yeah? Yes?
Hypothetically, could you like transfer over the electrons and have 2 double bonds? Like C double bond, C double bond.
C, double bond, C. It was only 2 C's.
Yeah, no, like H bond, C double bond, C double bond.
No, you're putting 3 C's. You're putting an extra C in there.
Oh, okay.
Yeah, there's only 2 C's. There's only 2 C's. Okay?
Got it.
Yeah, 3 C's. Isn't that like a soft drink? High C? No, it's high C. Sorry.
Double bond.
Non-carbonate. Yeah, exactly. So, okay, let's turn that off now. That's covalent bonding, molecular structures. Let's do a little molecular orbital theory next. But in reality, we're going to do some alloys that you don't know which is which, right? It's amazing. It's called special effects. You just never know, right? Okay.